Hello, in this video I'm going to show you how to use visual models to factor complex polynomials that have positive and negative values and leading coefficients other than 1. So the first one we're going to look at is x squared minus 7x plus 10. And I have to first look at the signs of these terms. So the x squared is positive. So right off the bat, I can draw a little square to represent that value. It's x by x. And I'm using color to represent the positivity or negativity or the sign of different values or different terms. So for this video, blue is positive and I'm using the red color for negative values. In my diagram, when I have two intersecting red lines, that's going to generate a positive value. Double negative makes it positive. And if I've got a red intersecting a blue, that's going to generate a negative value. Okay, so the center term being negative 7x is going to tell me something about this model. It's going to tell me that in the finished diagram, there will be more red bars than blue bars. That's what that negative 7 tells me. The second piece of information that I've got is that the constant term is a positive. So if the constant term is a positive, but I've got red bars, the only way that that's possible is if my 10 is being generated by multiplying negatives together, two negatives together. So I'm going to use the color to represent that information. So in my diagram here, I've already got my positive x squared. Now I'm going to represent my positive 10 using negative times negative. So that's a negative 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there's my 10 units that are double negatives resulting in positive 10. So in this visual modeling technique, the next step is to extend each of the lines, respecting the colors that I've already used. So I'm going to extend each of these lines up to complete a rectangular shape. Okay. And the result of that is I can see the dimensions of this rectangle that I've just completed are x, and I've got 5 negative bars, so that's minus 5. And the height of this rectangle is x and 2 negative bars. So the factored form is x minus 5, x minus 2. Okay, let's look at another one kind of similar. So x squared minus 5x minus 14. So in this case, again, that middle term is negative. So because the middle term is negative, I'm going to end up with more red bars than blue. The constant term is also negative, which tells me that it's going to have intersecting reds and blues. So I've got more red than blue, but 14 made out of intersections of reds and blues. So I'm going to draw that out. Here's my x squared, x times x. More reds than blues, so I'm going to go 7 times 2, so 7 bars, 4, 5, and they're too high, or too long if you like. So more red bars than blue. So this intersection of red blues that you see here is generating that constant term of negative 14. And then the finishing step in this is to just extend each of the lines that you've already drawn, respecting their colors, these red verticals are going to keep going right up to the top. There we go, I've got a nice rectangle, which means it is factorable. And the result is the dimension across the top here is x minus 7. That's 7 red bars across the top. And then x plus 2 down the side. So that's my factored form of that one. All right, let's try another one. X squared minus 3x minus 10. So again, center term or middle linear term is negative, which means there are going to be more reds than blues when I do my bars in. And the final term is negative 10. Therefore, it's going to have intersections of reds and blues. So here's my x squared. And then if I have more reds and blues and I'm trying to multiply to make 10, I've got to have 2 by 5. So 5 lines that are red and 2 high. 2 lines that are blue, like that. So this represents my constant of minus 10. And then just extend each of the lines that you've already drawn to complete a rectangle. And the result of that, the dimensions of this across the top are x, and the red bars are minus 5, and x plus 2. So there's the factored form of that trinomial. Okay, one more. So this one is similar to the first example that I gave. I still have more reds than blues in my bars. And the product, the constant, is positive, which means that all of my intersections on the bottom right, all of those units are going to be double reds. It's the only way to get red bars and a positive 8. So I'm going to go x squared and positive 8. So 1, 2, 3, 4 by 2. There's my first term and my last term. And now I extend each of the lines that I've already drawn to complete a rectangle, respecting the colors. You could use highlighter. You could do this with pencil and highlighter too if you wished. And there's my rectangle, which means this is a factorable trinomial. I've got x minus 4 across the top, 4 red bars, and x minus 2 on the side here. Okay, we're going to look at one that has a different leading coefficient to see how that changes things a little bit. So 2x squared plus 5x minus 12. So in this case, the squared value, there are 2 of them. So when I draw my model, I am going to draw 2 of those little squares. And I'm using 2 by 2 as my default for my square values, just because I'm trying to conserve paper. I could make them larger if I wish. It doesn't make any difference. All right, so this is 2 x's across here. And this is 1 x in dimension down the side there. Now my middle term is positive. So that's telling me that there are going to be more blue bars than red. More blues than reds because that middle term is positive. So if I look at 12, that can be broken up into 3 times 4. And since there's more blues than reds, the 4 has to be the blues. So 3 by 4, I'm going to go like this. So more blue lines than red lines there, because of that middle term being positive. This is my negative 12 that I've represented. And now I'm going to complete the rectangle just by extending each of the lines that I've already drawn, respecting their colors. Like that. And the result of that is dimension across the top is 2x minus 3. And down the side is x plus 4. So the factored form of this one is 2x minus 3, x plus 4. Okay, one more like that. We're going to do 6x squared plus 7x plus 2. So 6x squared is going to be represented literally as 6 little squares. And I'm going to draw that as a 2 by 3. You can play around with it because maybe the first time you draw it out, it doesn't work out to the right number of bars. That's fine. Okay, now these are all positives, so I know everything is going to be blue in this drawing. All positives, all blue. All right, constant is plus 2. So 2 is made by doing 2 times 1. So 1, 2. Like that. And then I just complete my rectangle by extending each of the lines that I've already drawn. Like that. So the dimensions across the top here are 2x plus 1. And down the side here, that's 3x's long plus 2. So my factored form of this trinomial is 2x plus 1 times 3x plus